Greetings, math fans. Alright, so today's topic is based on the previous lesson's topic where we found the slope of a tangent line. Alright, and now our topic today is there a tangent at x equals a? And some of you might say, well, it's pretty easy to tell because we're going to use our limit as h approaches 0, right? As we learned in the past day, right? Limit as h approaches 0, f of a plus h minus f of a over h. Well, yes, but we have to do two things actually. We got to check to see, first of all, is it continuous first? And then once we know it's continuous, then we can actually find the slope. So for most of these problems here, we're going to be given a piecewise function, and you will determine if a tangent exists at an x value. So it's going to be a given x value. Okay, so here's the deal. For a tangent to exist, two things must be true. Okay, the first thing is it's got to be continuous at that point. And the second thing, the slopes must be equal at the point. So let me just move down here a little bit and just give you the three scenarios. Okay, the first scenario is I give you something that looks like this. And I would say, does a tangent exist at x equals, let's just say at x equals 1, 2, as x equals 2. Well, no, it doesn't, so x equals 2. And you're going to say, no, it doesn't. And the reason is, well, first of all, it's continuous because you're always going to check for continuity first. So it is continuous, but the slopes are not equal. I mean, look at them. This has got a negative slope and this has got a positive slope. You can see the slopes are not equal, so there's no tangent. Okay, here's another example. We'll go to the same thing at 2, and let's say the graph looks something like this and like this. So at x equals 2, it is not continuous, but the slopes are equal, right? Because this is whatever positive slope, and this is also positive slope. So the slopes are equal for both of them, but you can see it's got a jump discontinuity, so there's no tangent. Okay, and our last example can look like this. So this is a quadratic on the left-hand side here, and it's linear on the other side, and it's continuous, and also the slopes are equal because this is whatever slope. This is basically just matches right into that second line. So in this case here, the tangent exists. Let me move this up a little bit so the x doesn't get in the way. Okay, so basically what we're going to do here is we're going to always check for continuity. Check for continuity first. And basically what you're going to do is you're going to plug in a point into both equations and see if equal. Okay? The second thing, once you do that, and again, this is really easy. That's why you're going to do this first. Okay? Because if you try to do the second part first, it's okay, but why do all that work with limits? Just to find out that it's not a continuous function. All right? So the second thing you're going to do is you're going to find the slopes of both equations, of course, we're going to use what we just learned, limit as h approaches 0. Okay, and well, I can write the rest of it out here, right? Limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so I've got a few examples to give you guys, and again, always check for continuity first, and then you want to check the slopes of both equations. Okay, so let's do that. Okay, your first example is f of x equals 3x minus 4 and x squared minus 2, and this x is less than or equal to 1 and x is greater than 1. And we're always going to check the critical point. It makes sense to check the critical point, which happens to be where the function changes from one piecewise to the other piecewise, right? So this is always going to match those numbers there. But let's go on here. If I check for continuity, okay, so we're going to say 3 times, we're going to plug that 1 in there. 3 times 1 minus 4. So 3 minus 4 is negative 1. And 1 squared minus 2, that's going to be 1 minus 2 is negative 1. So these are equal. They're equal, so it's continuous. Okay, so we're good to go. Now we need to check slopes. And so I'm going to plug in limit as h approaches 0, and basically finding the slopes of the 3x minus 4 and the x squared minus 2. So limit as h approaches 0, and I'm just going to kind of plug things in already, right? You guys should know it's a plus h. So it's 1 plus h minus 4 minus bracket 3 times 1 minus 4 all over h. So limit as h approaches 0 of 3 plus 3h minus 4 minus 3 minus 4 is negative 1 all over h. So limit as h approaches 0, it's going to be 3 minus 4 is negative 1, and that's plus 1 is 0, so I get just 3h over h, which is 3. So there's nothing even to plug in, so just slope of that one is 3. And then limit as h approaches 0 of x squared, so it's going to be 1 plus h squared minus 2 minus parentheses 1 squared minus 2 all over h. So we get 1 plus 2h plus h squared minus 2. That's going to be 1 squared minus 2 is negative 1, so it's going to be plus 1, right? Over h. Okay, so 1 minus 2 is negative 1 plus 1. Of course, that better cancel out. Remember how we did this the other day? Those constants better cancel out, so then I can factor out an h here, and I get h 2 plus h over h. They cancel. I can plug a 0 in here. 2 plus 0 equals 2. Okay, so that's this slope. These slopes are not equal, so there is no tangent at x equals 1. Okay, I'll move that up a little bit. No tangent at x equals 1. Okay, pretty mellow, right? Okay, let's do another one here. Okay, so f of x is equal to, same directions, is there a tangent at x equals a? So 2x squared minus 4 and x squared plus 2x. And this is when x is less than or equal to 3, and this is x is greater than 3. So my critical point I'm checking here is x equals 3, which is very obvious because there's the 3. So the first thing I'm going to check for is continuity. So I'm going to plug a 3 in there. 2 times 3 squared minus 4 is 9, times 2 is 18, minus 4, which is 14. And 3 squared plus 2 times 3 gives us 9 plus 6 is, 9 plus 6 is 15. Oh, not equal. There we go, man. So there's no tangent, because not even a continuous function. No tangent because not continuous. got a jump discontinuity. Okay? And let's do another one here. F of x is equal to 2x squared minus 4x minus 5 when x is less than or equal to 2, and 3x squared minus 8x minus 1 when x is greater than 2. And of course we're looking at x equals 2, right? Okay, so we'll check for continuity. That's going to be 2 times 2 squared minus 4 times 2 minus 5, which is 8 minus 8 is 0, minus 5 is negative 5. And 3 times 2 squared minus 8 times 2 minus 1. So that's going to give us 4, 12. 12 minus 16 is negative 4, minus 1 is negative 5. Sweet! These are equal, so it is continuous. That's good. And then we just need to check the slope at 2. So really this is not difficult, just gotta check for continuity and check the slopes. That's all you're doing. So we'll do 2x squared minus 4x minus 5 first. So limit as h approaches 0. Remember that's going to be 2 plus h, right, because a is 2. So 2 times 2 plus h squared minus 4 times 2 plus h minus 5 minus bracket, and then we're going to put a 2 in there, right? So 2 times 2 squared minus 4 times 2 minus 5. All over h. Woo! Limit as h approaches 0. And that's going to give us, just again, a couple steps here, right? That's going to be 4 plus 4h plus h squared minus 8 minus 4h minus 5 minus, that's going to give us 8 minus 8 minus 5. All over h. Limit as h approaches 0. So it's going to be 8 plus 8h plus 2h squared minus 8 minus 4h minus 5, and that's 8 minus 8 is 0, minus 5, so it's going to be plus 5, right? Because it's negative 5, so minus negative 5 is plus 5 over h. Okay, and cursor down here a little bit. Limit as h approaches 0. You see the 8's cancel, and the negative 5 and the 5 cancel. So I can combine stuff together here, and I get 4h plus 2h squared over h. And that's limit as h approaches 0 of h. So I'm just going to factor out an h here. So you get 4 plus 2h over h. They cancel. I can do direct substitution. So 4 plus 2 times 0 is 4. Okay? And yeah, I don't think it's enough room, so I'm going to actually just do it underneath here. This is 3x squared minus 8x minus 1. So limit as h approaches 0 of, and then we're going to put, again, 2 plus h in here. Squared minus 8 times 2 plus h minus 1 minus bracket 3 times 2 squared minus 8 times 2 minus 1 all over h. And again, showing some work here. So 4 plus 4h plus h squared minus 16 minus 8h minus 1 minus, that's going to give us 2 squared 4, 12. Oh, here's short. 12 minus 16 minus 1 all over h. Limit as h approaches 0, and that's going to give us 12 plus 12h plus 3h squared minus 16 minus 8h minus 1 minus 12 minus 16, negative 4, minus 1, negative 5. Hopefully all those constants cancel out. So limit as h approaches 0. 12 minus 16 is negative 4, minus 1 is negative 5, plus 5 is 0. Sweet! So 12h minus 8h is 4h. So 4h plus 3h squared over h. And then, of course, I can, let's just show here, it's limit h approaches 0, factor out an h, so 4 plus 3h over h, that cancels, and I get 4 plus 3 times 0, which is 4. So if we kind of go back here a little bit here, math fans, there's that 4 right here that we just figured out. Okay, and then we go up. Oops. Oh, there we go. And we're at that 4 there. So these are equal. I can show it there, right? These are equal. So slopes are equal. And if the slopes are equal, so let me highlight that. Slopes are equal. And we go to the top here, and it's continuous, right? We just found out it's continuous. So it's continuous, slopes are equal. What can we say? There is a tangent at A. So result here, there is a tangent at x equals 2. Okay? And you'll say that because it's continuous and slopes are equal. Okay? Not bad, right? Pretty easy to do. Pretty easy to do. Okay, the last thing we're going to do here, math fans, is we're going to use what we've learned now, getting that gap closer and closer, to find out. Remember how we did the problems with Purdue and with the Ford Mustang, where you said, hey, what's the velocity at a certain point? And we got points that were really close. Find the average rate of change. The closer we got with the points, the more accurate our guess was of the actual speed at Purdue or of the Mustang at a certain time or whatever. Well, what's going on is we're actually going to apply what we've just learned now with the limit as h approaches 0 to find, instead of our average speed, and to kind of guess at our instantaneous, now we're going to actually get a really close guess of what our instantaneous velocity is. Okay, so it's the same thing as finding the slope at a point, except now we just call it our velocity. So let's reset all of the screen here and show you what I mean. Okay, so this is instantaneous velocity. All right, and again, it's the same as finding the slope at a point. Okay, so your first example here is if I hand you a position function and it's s of t. S of t is position. S is usually position, and t stands for time. So 3t squared minus 2t meters. So I can give you units here too. And my question is, find the instantaneous velocity at 5 seconds. Okay? So you have your function, and I have my value of a. So we're going to do the same thing we did before. Limit as h approaches 0 of f of 5 plus h minus f of 5 over h. So familiar, right? We've been using this a lot now, but it's, again, we're applying it to a velocity or a position function to get velocity instead of just finding the slope of a line. Okay? Because remember, that's what kind of velocity is. Velocity is change in position, miles per hour. How is the position changing? It's changing at 5 miles for every hour. Okay? So let's keep going here. Limit as h approaches 0, and we're going to just plug that into our 3t squared. So 3 times 5 plus h squared minus 2 times 5 plus h minus bracket 3 times 5 squared minus 2 times 5 all over h. So limit as h approaches 0. Again, I've got to show some work here a little bit. So it's going to give you 25 plus 10h plus h squared minus 10 minus 2h minus, that's 25, so 75 minus 10 all over h. Limit as h approaches 0, so it's going to give us 75 plus 30h plus 3h squared minus 10 minus 2h minus 65 all over h. Limit as h approaches 0. 75 minus 10 is 65. Minus 65, is 0. So we have negative 2h and 3h squared and 30h. So that gives us 28h plus 3h squared over h. I can factor out an h. So h times 28 plus 3h over h. Cancels out. I can do direct substitution, which just gives us 28 plus 3 times 0, which is 28. So that's it, math fans. That's our answer. Now be careful of our units, right? It was meters, that was the position function, and I asked you what's going on in 5 seconds. So it's going to be 28 meters per second. That's your velocity, instantaneous velocity. Okay? I can ask you a couple other questions here. Find instantaneous speed. What's the relation between speed and velocity? Well, speed is just the absolute value of the velocity. That's all. Okay? Really, really easy. So actually, in this case here, the absolute value of 28 is just 28. So it's also 28 meters per second. Okay? And then my next question is find the average velocity between 4 and 6 seconds. Now, how is that different than what I asked for before? Well, I asked you for the instantaneous, so that's why you said h approaches 0. Now, you guys should remember this because we learned this back in the day, that average velocity is change in position over change in time. So it's basically the position, so f of 6 minus f of 4 over 6 minus 4. Okay? Really easy to do. So you're actually plugging it into our position. Now, of course, it's s of t. No big deal. S of t is the same thing as f of t, right? I plug a 6 into there, so 3 times 6 squared minus 2 times 6 minus bracket 3 times 4 squared minus 2 times 4 all over 2. So that gives us 6 squared is 36 times 3 is 108 minus 12 minus, and that's 16 times 3 is 48. Showing a little work here. Minus 8 over 2. So it gives us 108 minus 12. And then that's minus 40 gives us 56 over 2, which is 28 meters per second. So very interesting, actually. The average in this case here, just kind of random, but the average is equal to the instantaneous, which meant if I actually would have said, because I asked you guys what was the speed at 5 seconds, the average would have been a really good estimate. In fact, it would have been a right on the money estimate of the instantaneous. Okay, because remember, you take the 2 points and they're closest on either side to get our answer. So we can just write there the average velocity was a good estimate of instantaneous velocity. Okay, so that's it, math fans. Again, really the 2 things we covered is there a tangent at A. It means you're checking for continuity, you're checking slopes, and then we talked about instantaneous velocity, which is just what we've been doing before. You're finding the limit as h approaches 0, shrinking that gap, so you're actually getting instantaneous velocity as opposed to average velocity. And then knowing what speed is, and kind of a little review on average velocity. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.